Hello and welcome to the Data Engineering Podcast, the show about modern data management. RudderStack makes it easy for data teams to build a customer data platform on their own warehouse. Use their state-of-the-art pipelines to collect all of your data, build a complete view of your customer, and sync it to every downstream tool. Sign up for free at dataengineeringpodcast.com/RudderStack today. This episode is brought to you by Datafold, a testing automation platform for data engineers that finds data quality issues before the code and data are deployed to production. Datafold leverages data diffing to compare production and development environments and column-level lineage to show you the exact impact of every code change on data, metrics, and BI tools, keeping your team productive and stakeholders happy. Datafold integrates with dbt, the modern data stack, and seamlessly plugs in your data CI for team-wide and automated testing. If you are migrating to a modern data stack, Datafold can also help you automate data and code validation to speed up the migration. Learn more about Datafold by visiting dataengineeringpodcast.com/Datafold today. Your host is Tobias Macey, and today I'm interviewing Ariel Pohoryles about the 7 principles of modern data pipelines. So, Ariel, can you start by introducing yourself?
Sure. Hey, Tobias, thanks for having me on the show. So as you mentioned, my name is Ariel. I've been in the data space for around 20 years now in different roles and types of organizations. I started my career as part of now it's called data engineer. Back then it was just a data professional in a large organization, large corporation, part of the internal data team, developing data pipelines and reports internally. I then moved on to a product company in the data analytics field, working with organizations, evaluating technologies and helping them choose the right one. And later on, I moved to lead a data consultancy, helping an organization implement those different data products that are available out there on the market, and obviously their own custom solutions. So I'd like to think I've been kind of in all angles of the data lifecycle, the data implementation lifecycle. So the part I've liked the most was always the product part, where I find the innovations coming through at a faster pace, and that's why I've recently joined Rivery. I'm leading the product marketing here at Rivery. If you haven't heard of Rivery, we are a startup in the space of data integration. We offer a SaaS DLT platform that really simplifies end-to-end data integration processes, with starting with no code all the way to low code and even high code options in the platform that handles everything from data ingestions to data transformations, orchestrations, even reverse ETL, all of that with solid foundations of data ops management to simplify the process. So a bit of an intro about myself and who I work for.
Yeah, and for people who do want a deeper dive on the Rivery product itself, I did do an interview with one of the founders a little while ago, which I'll link in the show notes. And in terms of your experience working in the data space, do you remember how you first got started working in data?
Yeah, I actually majored in the information systems. So data was always on, I guess, my kind of natural career path coming out of school. I actually, when I was graduating, I already started working for a small company named Intel as part of their internal data team. So I always been in and around data. I think fortunate to choose a field that I think is becoming more and more important to businesses that they keep on improving the offerings and operations using data. And to me, what's interesting is that it's also true to our not just our professional life, but also kind of our day-to-day life. Data is really everywhere, and kind of having studied and worked in the field for so long, from my perspective, it's really great to see how data is helping bring value, again, not just to businesses, even just to our day-to-day life.
And for the conversation at hand, at Rivery, you published a white paper identifying 7 principles of modern data pipelines. And before we get into that, I want to start by getting a definition of what you mean by modern in the context of data pipelines.
I think when you start a discussion around what modern is, it's very easy to focus on the technologies behind it. Is it cloud first? These days, obviously, does it have AI, generative AI in it? And I think, yes, that's obviously a big part of what modernizing is. And definitely the cloud first is a huge component of what a modern solution looks like. I always like to think about it from the reasoning perspective of why we need those technologies in place. And when I started my career as a data engineer, again, back then it wasn't called data engineer, I was dealing with very different requirements for data pipelines. Data pipelines back then had very few data sources they had to ingest data from. In most cases, it was a single database, maybe a simple CSV or Excel file. I typically had a single target to load data into. It could be a SQL Server database on-prem. That was kind of the popular choice back then. I had pretty small data volumes that I had to ingest, and the business requirements were calling for data to be I loaded maybe once a week, sometimes even once a month on month closure. Today, data professionals really need to deliver data pipelines that are much more complicated across all those aspects. There's many more data sources they have to ingest data from, starting from internal data sources, but also a huge amount of external data sources. There's 30,000 SaaS applications out there in the world. So each organization on average is using about 40 to 400 SaaS applications. That's a huge amount of data sources that the data could live into to be ingested into a pipeline. The data volumes we deal with are far greater and larger. The whole big data era is now gone in terms of a buzzword, but still data volumes are much more significant than what I used to have when I built my data pipelines back in the day. We see that the data pipelines do not just end in one single database. They actually need to go and maybe ingest data into a data lake and then into a data warehouse. So maybe there's multiple data warehouses. Sometimes if you really push the solution, you also go and bring the data not just into a lake or a warehouse, but you actually bring it into an operational application. So that aspect has changed as well. And of course, the data latency, the businesses are now asking for the most part as close as possible to real-time, near real-time data delivery. So all those aspects are really what, in my mind, defines what a modern data pipeline needs to provide. And yes, being cloud first is a key component to be able to deliver on those requirements. But first and foremost, that's what a modern data pipeline is in my mind. They be able to deliver on those requirements that the business needs.
And just to add some juxtaposition as well, I'm curious, what are some of the aspects of, if we're talking about modern data pipelines, then the corollary is probably legacy data pipelines or old data pipelines, and wondering what are some of the characteristics of that set of practices, whether it's technological or organizational, that are failing to keep up with the current set of requirements around data usage in organizations.
Yeah, so we've categorized this as 7 different principles. You mentioned technology. That's definitely where it starts. I talked a bit about being cloud first. I think that's a key component to be able to set up an infrastructure that can scale and keep up with the pace of the modern data pipeline. Essentially, the current business requirements of being able to set up a new data pipeline very, very quickly. So you need an ability to do that without having to deal with infrastructure management, zero infrastructure management. Obviously, that's what the cloud provides. The whole shift from an ETL approach to an ELT first approach, where you first bring the data as quickly as possible and then transform it in place and benefit from the cloud endless compute power, from the ability to then leverage and use that data for other use cases. So moving into an ELT first mindset, I think that movement has started ever since. Redshift has been around for about 10 years, and obviously with Snowflake and other cloud data warehouses that becoming more and more standard. The way you would configure those data pipelines, again, to be able to support the speed of delivery that the business requires, I think that's another important aspect. We used to see systems that were quite heavy in terms of user interface with a lot of options to drag and drop and configure different components. I think we're seeing a move away from those heavy GUI-based applications because it just takes longer to learn those applications and the different knobs and features you could have with those types of interfaces. And so the common approach to reduce the learning time is really just to use a system that everybody can learn and pick up in a few days. And that means that system needs to be able to speak common languages that everybody speaks, which is in the data world, SQL and Python. So as long as the system enables you to do transformations and bring your data in the way you want to with SQL and Python, I think that's a key component to be able to modernize it and deliver on that time to value that the business is asking for. The fourth principle we noticed more and more in the past years is the need to really support multiple storage layers for our data. It used to be that all the data could live in the warehouse. Data volumes, cost of storing those large data volumes, as well as different applications and use cases, start dictating a different architecture where data needs to be stored in different locations. Sometimes it is in a data lake, sometimes it is in a warehouse. Sometimes an organization has a hybrid approach where they have multiple warehouses in place, even the biggest rivals. And so being able to really store data in the different locations, I think that's a key component or principle to give us the flexibility that we need to support the different use cases of a modern data pipeline. And then the last three is about, I think, really showcasing the value of the modern data pipeline, and especially in 2023, where every expense is being scrutinized, budgets are tightening, and we really want to show the value for each business operation that we take. The ability to use the data in the most efficient fashion is key. And that starts with really bringing the data not just to a storage layer such a lake or a warehouse, but actually to business applications where the business users are working and operating. What's known in the industry as reverse ETL. So being able to support that in a data pipeline is key as well, just to be able to close that last mile and bring more value faster to our users by providing the right data point in the right place where they operate, and not locked in a warehouse or a lake where it's harder for them to access that data point. The ability to manage all of that, we're talking about a single data pipeline, but the reality is that in every system that we architect, there's many, many, many different data pipelines or many, many different jobs that execute different data movement operations. So being able to really see where the data is, where it's being blocked, if there are some failures, being able to respond to those very quickly. So getting full transparency into what's happening, both from a health perspective of our data movement, but also from a cost perspective, as I mentioned earlier. I think these are critical components to be able to deliver on both the consistency and the quality that the business requires from our data, but also maintaining the spend at a low level and optimize as much as we can. And it all really comes together in kind of the ability to do so very, very quickly. So everything that could be commoditized from a data pipeline perspective, and there's a lot of components that used to take a lot of time for data engineers to develop, such as, for example, coding against a certain API of an application or data source you want to ingest in. So there's many different tools like Rivery, for example, that provides that no-code experience, take away all the management of those APIs, and really provides the ability to, in a few clicks, bring the data from Salesforce, from Shopify, from Facebook ads, from all the different data applications and sources you work with into your business applications very, very quickly. That's one example. We see other areas of the data pipelines that can be commoditized, such as the way we manage increments and loading data into our warehouse, the way we map the fields from source to target. All those things are different components that can really be streamlined and provide the ability to the engineer to move much faster and really focus on the way you deliver data to the business and model it versus the way you actually ingest it and bring it to the target. So that's what really combines the last principle of really being able to deliver much faster and bring value faster to our users.
So in the process of identifying and codifying these different principles, I'm curious what the main areas of focus were as far as the ways that data was going to be used. So data is a very amorphous concept. It can have multiple different applications. Most of the time when people are talking about data engineering, they're talking about it in the context of business analytics, where usually the consumer will be some sort of business intelligence. You also mentioned reverse ETL, which to some degree fits into that same flow of I need to be able to understand and act on and support my core business needs for analytical purposes and being able to feed that back into the operational aspects. Obviously, there are also cases where machine learning is the target consumer. There are user-facing analytics. There are cases where the data is actually being used for scientific research purposes or just statistical analysis. I'm wondering what were the main points of focus that you were looking to identify these principles and how universal they are to those to this breadth of applications for that data?
Yeah, great question. When we started the Rivery, what we saw initially is a lot of customers coming to us with a use cases or applications around marketing data. Marketing is a huge world. I don't know if you've ever seen those MarTech visuals that shows the different number of applications that exist in the MarTech world, which is growing exponentially, I think, every year. So a huge amount of data applications, essentially SaaS applications, typically that marketeers work with, and they need to pull data from those different applications to fulfill their different use cases. So it could be a use case where they're trying to analyze ad spend across their different ad channels. They have data in Google Ads. They also have data in Facebook ads, LinkedIn ads, Bing ads, being able to see all of that together in a single view and provide or analyze the right ad spend per channel. We see obviously digital agencies analyzing social media data, trying to segment audiences based on the right social media channel and understand what converts best down their funnel. So these are the initial use cases in business application that really helped us understand what is required from us when we deliver a product that enables the creation of this modern data pipeline. They came with good number of different applications and data sources. One of the things that we noticed very, very quickly is that it's hard for us to keep up with the number of applications they bring in every day. There was just endless number of SaaS tools that they wanted to connect to. And so many of those, the popular ones, of course, we created a no-code experience out of the box that had the managed APIs for those data sources natively. But then we also saw many other kind of niche marketing applications that each organization used for their own specific requirements. And so for us, one of the things we need to do is to deliver a mechanism that enabled a quick connectivity to those what we call custom applications that we don't have natively offered in our tool, but still maintaining those principles of zero infrastructure management, very quick time to value, full transparency. So that is one of the things that we had to add to Rivery is to make sure we have the option to really build custom data connections to any SaaS application out there just via low code configurations of a few endpoints that we populate in that kind of a specific pipeline that pulls data from those custom applications. So that was a kind of an eye-opening experience for us working with this type of organization, not just the classic organization that has the common application that everybody else sees, but also the niche one that are harder to find connectors for. The other thing that we saw working with those organizations that had marketing use cases is the need to be able to scale those types of data pipelines very, very quickly. So, for example, a digital agency typically serves a lot of different customers with very similar data extract and data transformation across different data sources. So they always pull data from, let's say, from Facebook and TikTok and other channels, but then they had to do it in the context of each one of their customers. So again, the zero infrastructure management plus a few other capabilities that allowed us to create what we call a multi-tenant data pipeline experience. That was key for us to be able to deliver on those requirements that those digital agencies had. Lastly, I would mention is that because the marketing teams that we worked with typically had both their own marketing data analyst as part of their team, because their work is so involved with data, they had a budget to justify an internal role that they was dealing with data in their team, which was not part of the centralized data team of the organization. So for them, kind of having that flexibility of being able to build a data pipeline very quickly without having access to everything that the organization has at the centralized level was key. And the other piece that was key there is the ability to connect it back to their business applications. And this is where the reverse ETL that we talked about comes into place. Because they were so close to the business, they always identify those use cases where data could go beyond the warehouse where typical centralized data engineering team would stop and bring it back into the business application. So I think a lot of the principles that we've developed over the years came specifically from those initial marketing related use cases that we tackled in our early days.
It's easy to get lost in the technical aspects of the work that we do because there is a lot of technology and algorithmic aspects to the work to be done, but the end goal is to empower business use cases and have an impact on the real world. And I'm wondering what you have seen as the application of these principles and that their ability to influence the capacity for organizations and their data teams to keep up with the use of and requirement for data in these business contexts.
Yeah, I agree with you. I think it's as a data geek, for me, speaking about technology is always a lot of fun, and getting into how this operates and how that tool can do one thing or another is very interesting. But at the end, it's about how those organization can keep up really with the pace of the data that the business demand. And obviously, it's not just about delivering the data, but delivering data in a way that is usable with the right quality level, with the right consistency as well. And so the foundation to all of that starts with the ability to move very, very quickly in a simple fashion. So many of the principles that I've talked about relate to that ability to deliver faster. And if we look at the foundation, it's really around the fact that you don't need to manage infrastructure, for example. You have zero infrastructure management because using a full SaaS ELT architecture allows you to shift the discussion from, oh, I need to set up a VM, and that VM needs to have X compute power, I need to maintain it and all that, into let's just focus on the data that we actually bring to the business and build that pipeline very, very quickly. The other thing that we saw is to keep up with the pace of the business, we need to make sure that the business realizes that data is delivered to them. And so it's kind of like an endless loop. The more they see data being valuable to them, the more they would ask for it, and the more use you would get out of your architecture and your solution in place to really drive your end goal, which is making better decisions with data available to us. So that delivery of the data to the right place where the business operates, it was key to us. And the ability to really do it in a flexible fashion, not just in the common set of applications they use, but the specific ones they care about, we saw it being a major game changer for our customers. So I can give you a few examples. There's common applications that store your data, such as Salesforce and HubSpot and tools that a lot of organizations use these days. So reverse ETLing into those applications is kind of a basic one. But even just bringing the data into more unique applications that the business users are using, or into just their tools, which are not necessarily data tools, but just communication tools. For example, we have a lot of customers that actually take business insights and push those directly into Slack channels in a very sophisticated way. So those Slack notifications are being sent out based on very specific triggers with the unique insights that helps the business users move faster on their operational tasks. This is something that I think is key to really make sure that the business keeps on demanding data at the fast pace that they do, and along with the other infrastructure benefits that I mentioned before, enable the data teams to deliver that data at that pace.
Now, digging into that technical aspect that most of the people listening to this show are actually interested in, I'm wondering what you have seen as, at least in broad strokes, the core requirements for a pipeline infrastructure that can support these principles of the modern workflow, and some of the ways that teams should be thinking about the tool selection and evaluation for building up their technical capacity to deliver on those business needs.
Yeah, absolutely. So I mentioned the word cloud multiple times. I think it can't be stressed enough. We still see a lot of ETL tools out there which are not really SaaS-based tools, and I think that's really at some point going to be what creates the bottleneck and slows down the implementation of your data pipelines at the speed that the business demands it. So obviously having the right infrastructure, which is cloud-based, that can scale up and down very rapidly and meet your demands is key. Without having to manage it. It's not just about the management of it. It's first and foremost about the infinite scale that you need to have, because as we all know, data volumes just increase every day, and we just need to be able to support that without having to spend all our resources and effort on managing the infrastructure. But beyond the cloud foundation here that I think is a must these days, I think what we're seeing is a movement of a lot of no-code tools being stitched together, almost duct taped together to form what's called a modern data stack. And each one of those tools is very good at handling one part of your data pipeline. So if it's the starting point, the ingestion, where you pull data from different applications and have that no-code experience with the managed APIs that I mentioned earlier, that's great. But then obviously that's just the starting point. It's not a full ELT. It's just the EL part, if you will, of the ELT process. Then you need to transform the data. So then you have to bring another tool that will help you take that ingested data and turn it into business insights. And if you have many of those pipelines running together, then you need to have an orchestration engine, both trigger advanced scheduling and logics, but also allow you to manage that entire operation and make sure it's healthy. And finally, if you have budget, you may need to bring another tool also for the reverse ETL aspect of the pipeline and bring data out of your warehouse back into the business applications. So I think the ability to combine many of those operations together into a single platform that maintains those principles and don't overcomplicate things, but actually simplifies things in fewer integrations, a simple kind of seamless interface to see it all in one place. That's a big part of what allows you to modernize much faster and move with less moving parts along the way. So if I'll summarize it, it's about being on a cloud-based infrastructure, of course, but trying to make sure that you don't over-architect your environment and choose the technologies that really allows you to get to your goal as fast as you can. Because what we see these days, it's mostly a question of speed. How quickly can we answer and satisfy the business needs? How quickly can we provide the data that answers the next question? And the technologies that will win are the technologies that allows us to move faster versus being bogged down with integrations, infrastructure, maintenance, long learning curves. These are the ones that will slow us down.
In that suite of technical capabilities that are useful and or necessary, what are some of the ones that in your experience have been the hardest to implement, or maybe some of the aspects that have required the most conversation with data teams to convince of their value?
Yeah, that's in my mind, often a question that comes down to kind of the build versus buy. I think many talented data engineers out there like to write code. That's part of what they've learned and what they enjoy doing. And so a lot of the conversations that we have is around the value of using no code for certain operations they have and trusting the system that they will do whatever they need to do. So I think there's an understanding, a growing understanding out there that parts of data pipeline can be fully moved to no code experience, and the more transparency you give to the user about what's happening behind the scenes, obviously the better, and that makes for a better experience for those users to trust those tools. We still see the need to kind of convince around the cost of running your operations with a combination of your own coded solutions as well as no code where and when you can use it. And so I think that's one of the biggest challenges. How do we combine and marry all those things together and make sure the data engineers sees the value of leveraging kind of those managed solutions that shorten the time to value and help them to focus really where they need to focus, which is about bringing data in the way that it can be consumed and with the right insights versus focusing on just bringing the data itself. So I think that's still where we see many of the conversations happening. And I think most organizations that choose to modernize, they do realize that the hybrid approach where you can combine no code and low code is kind of the best approach, but that's still a challenge depending on the persona you have in front of you, whether they come from a no code first approach or a code first approach, kind of helping them realize that there's a balance between them, and having that flexibility to deliver on the more complex requirements is something that's required to be able to satisfy the requirements as they get more and more sophisticated by the users.
To that point of the users, that in general is the whole business and the capabilities and the interfaces to the tools that are used for managing the data flow, including things like onboarding new data sources, bringing it through to a point where it's ready for analysis. The way that the tool is represented can have a massive impact on who is able to do those operations. And with the idea that data engineers are already overtasked and generally end up being the bottleneck, what have you seen as the organizational impact of making tool selections that reduce that barrier to entry and reduce the friction involved in bringing more people into the process of working with the data?
Yeah, 100%. I think almost every conversation we have with a customer around why they chose Rivery starts with, we used to have a legacy tool, and I knew I needed an army of data engineers to maintain and learn how this tool works. And with Rivery, I could take a few data analysts and in a few weeks' time, have them building end-to-end data pipelines without being ETL experts ahead of it. So yeah, I think it's definitely expanding the type of users that can build pipelines. As I mentioned, data analysts are becoming more and more of heavy users. If we think maybe in other terms that they are known in the industry, so you have data engineers, these are typically the guys that are comfortable coding. Then you have what's called the BI developer, and some of those are comfortable in Python and in other languages. Some of those users are really just building dashboards in Tableau and other tools, and maybe they know SQL, but they're not familiar at all with infrastructure considerations, stuff like that. For these users to be able to come in, plug in their credentials to their data source, and then configure a data pipeline is a huge game changer. And I think we see more and more trust from data engineers to open up kind of the keys and environments to those users to build the data pipelines, obviously with the right checks and balances. But that really is a big part of shortening the time to value. To your point, opening the pool of users that can leverage those tools. So definitely, data analysts, BI developers, system analysts are now able to build data pipelines as well with that, and I think that's a huge game changer. Kind of the whole approach of self-serve that Tableau, Click, and others kind of brought to the data visualization world is now happening in the same fashion to the data ingestion or the ELT world.
Another aspect of the tooling question and the impact that it has on the use and adoption of data, particularly at the organizational scale, is the question of balancing price with usage, and some of the ways that when you're using managed services, or even if you're using self-hosted, the impact that the incremental cost of new pipelines, new data has on whether or not an organization decides that they want to invest in that expense, and some of the ways to think about the cost, both in terms of monetary but also opportunity cost of maintaining these systems, how that reflects in the ways that businesses are applying data to their operations.
Yeah, so cost again in 2023, cost is a very important question that more and more data teams are evaluating. They're evaluating the ROI they bring to the business. They evaluate every aspect of it, both the value side as well as the spend side. And so I think managed services, as you mentioned, oftentimes pricing those services with a usage-based model is a great vehicle to really fine-tune the cost and the spend, and make sure that you really find those use cases where data brings more value to the business without having a huge investment upfront. Of course, you need to make sure that your managed service provides you the tools to be able to understand what's happening in it. I think for Snowflake, for example, for years and still now, it's an ongoing challenge to understand where is my Snowflake costs incurring from, how can I optimize it. There's a lot of tools that both Snowflake themselves and many other partners of Snowflake have developed over the years to help you manage that cost better. The answer is not always, just use a managed service that's going to be cheaper. Of course not. But if you want to find those avenues where you can reduce your cost, optimize it, and still, again, I'm going to go back to the speed, because I think the speed is the most important thing these days, to be able to provide on the speed with rapid experimentation and exploration of different avenues. The way to go is with a usage-based pricing model that is provided by those managed services. And typically that comes together with all the benefits of the managed service that allows you to get that speed, the no-code experience, or all the other items that are taken care of that you would need to set up yourself if you were to go and code it, for example. Again, the trick is to find or make sure that you have the right visibility into how that managed service operates and what cost is going to be incurred out of it. It's not always simple. A lot of the pricing models are trying to be tuned to metrics, to pricing metrics and value metrics, which are really about the value at the end, but quantifying those from a technical perspective and understanding how those would operate. For example, how many rows I'm going to ingest for a certain source is not always very easy. A data engineer doesn't always have a good idea of how many rows exist in that data or how many rows will update every month. So yes, that's the value that you would eventually bring to the users, new data. But how do you understand how much that's going to cost you? It's not always a simple task. I think there's different pricing models out there, obviously from the different vendors. It's interesting to compare those and see which one works best. But in my mind, there's no question that a usage-based pricing model is the way to go when you want to be in a world that is modern, that provides that speed that I'm talking about to deliver to the business at the right time.
In your experience of working in the industry and more recently working at Rivery and codifying these principles, I'm wondering what are some of the most interesting or innovative or unexpected ways that you've seen teams applying these 7 principles, both at the technical and the organizational level, or any interesting aha moments that you have experienced when talking to customers about these principles?
Yeah. Yeah, I think I could probably dissect each one of those principles and apply it to where it was interesting or innovative in their use case, particularly. But I would say that many of those principles are true to almost any technology, not necessarily just data technology. Um, what was interesting to me was that movement of reverse ETL that I mentioned earlier, and seeing how we're closing the loop and how we're bringing the data and delivering it to the right place much faster than the old paradigm of let's just learn it in a warehouse and some analysts will come and put the BI tool on top of it and then analyze it. So that ability to really push the data into the right application at the right time, to me, that's a world that opened a lot of interesting use cases that I've seen. I've seen some of our customers doing a whole closing a system of the month end in applications like NetSuite, for example, where you have business users coming into NetSuite and they need to decide which deals are going to be recognized in this month's books versus next month's books. And so they look at the list of deals they have, they check a few and say, okay, what's going to happen to my bottom line if I recognize these deals in this month, and what's going to happen to these deals in that month. And then as they want to simulate and analyze those scenarios, they just trigger from NetSuite directly a job in Rivery that processes the data, ingest it from the different booking systems, bring it back into NetSuite, and presents the bottom line as it's going to look like in this scenario. And then when they're happy with the right mix and the right scenario, they go in and they even have the option to lock that and say, okay, that's the final version of the truth I'm going to have for this month closing. And so this type of use case where I have not even a data analyst, but just a financial person, a business user running data pipelines seamlessly from within his own business application without even knowing that behind the scene Rivery is running, but still getting his job done using the data in almost in real time. To me, that's a really cool and interesting way of bringing data as close as possible to the business users.
And in your work of developing these principles, helping customers adopt and adapt to these principles, what are the most interesting or unexpected or challenging lessons that you learned?
I think around technology, there's lots of challenges that are ever growing. I mean, there's always new integrations, new technologies to support, new even new systems of storage. Lakehouse from Databricks, for example, is does not behave like a Snowflake data warehouse, for example. So that there's obviously lots of challenges around that from technical implementation perspective. But to me, what was interesting to see is more from an organizational perspective, how organizations are turning to be more and more a hybrid. I think the approach that we used to talk about all the time about kind of one source of truth, all my data is hosted in one data warehouse. I think that is changing more and more, especially with the ease that we have these days to spin up a new environment. And I think that's fine. We start seeing different architectures and concepts to be able to manage and make sure that our data is still accurate, even though it's stored in different layers. So that principle of data being stored in different locations across the business, to me, that was a kind of the most interesting evolutions or lesson in the last few years. And so I think that was the key principles that we had at Rivery as we started to develop the system, is to make sure that it's not monolithic in the sense that it's always going to load data into the same storage layer. It has to be flexible enough to support organization that shows Databricks as maybe the primary lake house or warehouse kind of storage location, but then they also have maybe an HR unit that is using Snowflake, because maybe Snowflake is a bit simpler for those HR analysts, and they need the option to be able to operate their own data pipelines obviously it's HR data, so it needs to be very, very secured and sensitive. So in a way that's almost completely isolated from the rest of the organization and the rest of the data engineering team that loads it into Databricks. So to me, that was quite interesting to see how that's evolving. And I think we're going to see more and more of that happening with shifts of data in and between systems. So one of the new areas that we're investing more and more is to be able to ingest data not from source applications that we traditionally had, RDBMSs and external SaaS applications, but also being able to ingest data from a data warehouse and load it into another data warehouse, not just for the sake of migration, but even just for the sake of syncing data across systems and making sure it's all up to date in all locations. So that's, I think, an interesting evolution that we start to see more and more as we develop kind of those principles and thought about, okay, we need to support multiple storage layers and destinations.
And for people who are hearing these principles, thinking of ways that they might be applied within their environments, what are the cases where some or all of these principles are either undesirable or impractical to implement?
Yeah, I think a big part of this foundation is based on cloud technologies, being able to obviously have zero infrastructure management, or be able to use an ELT approach versus an ETL approach. Those kind of elements obviously exist only in the cloud. So if you are forced to use an on-premises deployment, for different reasons that exist out there, whether it's regulation or something else that your businesses chose to use, then obviously I think you're losing a lot of those principles, or you can't really implement them in the same way that I'm talking about. But if you are moving to the cloud, or if you're already in the cloud, obviously I think those principles are really cross industry, cross verticals, and there's no limitations on using those in that scenario.
And as you continue to work with customers, keep an eye on the constantly evolving landscape of data and its applications and the ways that teams are working with it, what are some of the opportunities that you see for further advancement and sophistication in the ways that teams work with and gain value from data?
I think you can't have a conversation these days without talking about generative AI and how that can make a big impact on all of us in all different areas. I think that's definitely true for data teams. We see a lot of early days, but still a lot of tools out there already evolving around helping you to write SQL faster, helping you to speed up your processes, maybe gain better visibility into your pipeline's health, understanding quality issues. I think this is where we'll see more and more advancements and sophistications. And again, all in the goal of kind of shortening time to value. Obviously, at Rivery, we have our own kind of thoughts on that and plans that we have around how we can leverage generative AI to improve the experience for our users and really speed up the development. And I'm sure I'm not surprising anyone here, but I'm pretty confident this is where most of the advancements will come in the coming months and years to come.
Are there any other aspects of the work that you're doing at Rivery and the application of the 7 principles that we've been discussing that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, that's a great question. We've touched upon different questions earlier in this discussion around maybe the need that we have to stitch too many tools together and duct tape them, or add aspects that we've mentioned around the complexity of kind of legacy tools and the learning curve that they involve. But I think the biggest challenge that we see these days is the ability to find the right balance between the simplicity that we want to bring to the users, and at the same time the ability to solve for the more complex use cases. I think there's a lot of tools out there that they are just kind of growing over many years, and each version that's being released, there's more and more features added to solve for more specific scenarios and complex use cases. But again, learning those tools take a very long time. Just understanding that the options are there to solve those complex use cases is quite hard to find. And on the other hand, we have tools that kind of went on the other side of the pendulum, and they oversimplify the approach to data management. Sometimes those tools just focus on one very small part of the data management lifecycle, if you will, and they then force organization to use those tools along with a lot of other tools or side solutions that those organizations would be forced to develop to meet their unique scenarios. So I think that's, in my mind, the biggest challenge that we see in most tools is how those tools find the right balance between providing an easy experience for what should be easy, and at the same time still provide the avenues and the capabilities to solve for the more unique scenarios and the complexities that they arise from ever-changing business requirements. I think it's going to be an ongoing kind of challenge. But when I look at the tools on the market, I think most of those tools, they either swing over one side or the other side. Obviously, at Rivery, we try to find kind of that happy path that's able to simplify what should be simple and to provide ways to solve what's a bit more complex. But still, that's kind of the biggest challenge I see and gap in many tools. And as you look at the way those being applied to provide a solid data architecture to manage your data. I think that the solution to power that is definitely to combine a lot of those modern data pipelines principles I mentioned earlier and try to deliver as many of those in less tools in maybe a single platform or a couple of platforms together, but not too many platforms as we've seen too often in the common kind of what's called a modern data stack implementation. So in my mind, that's one way to increase the simplicity, but still provide the flexibility. But I think there's still a lot of room to keep on fine-tuning and find the right balance to decrease the gap and really let the users focus on the business value versus trying to learn and understand what technology is powering it. Because at the end of the day, I think the technology is just here to provide an abstraction layer to the way we use data. It's not about technology. It's about what we do with the data. And I think that's what the tools that we use for data should be focused on.
All right. Well, thank you very much for taking the time today to join me and share these principles, the ways that they apply to the business, ways that they can help teams get more done faster. I appreciate the time that you and your team put into condensing this information and presenting it to us, and I hope you enjoy the rest of your day.
My pleasure. Thank you very much for having me. Have a great one.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.